Hello everybody, we're going to talk about histograms now. Histograms are a way to represent data that are kind of like just a tally sheet, but a little bit more organized than that. So the first example I'm going to do is I'm going to roll these dice, and then I'm going to mark down the results that I get for each one. So if this is a 1, 2, 3, 4, 5, 6. So it looks like I have 1, 1. So I can mark that off. And it looks like I have 2 2s. And then 2 3s. And then 1 4 and 1 5. And I didn't roll any 6s. So this is a simple example of a histogram. And you can look at it as each bar shows how much of each roll we had. So it could be done in a different way if we wanted to maybe just say how much was there from the 1 and 2. So this is like 1, 3, 5. You know, if we wanted to see how many were between 1 and 2, there was actually a 3 there. And then 3 and 4, there was 3 there. And then 5 and 6, there was just 1 there. So this is kind of changing the range, relative frequency of each number. Okay, so and then if we wanted to look at the histogram that was just the bottom 3 numbers, so like 1, 2, or 3, and then 4, 5, or 6, then there would be, let's see, 1, 2, or 3, there was 4 or 5 of them. And then 4, 5, or 6, there was only 2 of them, so that's interesting. So this is a way that you can do histograms. Now, there are ways to look at histograms that appear all over the place, and this is a very small data set, but if you had a very large data set, you would find out that the frequency of each number would be about the same. It could be off by a little bit, or higher or lower, but it's going to be relatively the same for every die. So 1, 2, 3, 4, 5, or 6. This is kind of a flat distribution. Now, if I were to roll 2 dice and I make the total, so there's 8, for example, then I'll go ahead and, so what are the possibilities? It could be 1, 1 would be the lowest, right? That's a 2, and so that would be the lowest possible number. You can't actually get a 1 because you can't roll a 0. And the highest number is 6 and 6, which would be 12. So that's the highest possible number. And then everything in between, right? So I rolled an 8. We'll go ahead and mark that down. And I'm going to do a whole bunch of rolls of just 2 dice and see what kind of distribution comes out. Okay, so I made a bunch of rolls and I marked them down on this tally sheet, giving you a histogram of the possible, what I actually rolled, given 2 dice, so there's another 6. So you can see that 7s, 8s, and 9s were rolled a lot more than the other numbers. And this is to be expected because when you look at the dice, the ways that you can roll a 2, well, there's only one way. And the way you can roll a 7, well, you could roll a 1 and a 6, you could roll a 2 and a 5, you could roll a 3 and a 4, or you could roll a 4 and a 3, or 5 and a 2, or 6 and a 1. So there's a bunch of different ways that you can roll a 7, but there's only one way you can roll a 2 and only one way you can roll a 12. And actually I didn't roll any 12s, which is only if you roll a 6 and a 6. So there are different distributions that happen, and this is not quite a perfect bell curve yet. If you roll 3 dice at a time and do the total on them, it gets even more likely that you will get what is called the median, right? So the median to be, I think it's 10 or 11, or maybe 9 or 10. It's kind of in between the two. And you'll get these things called a bell curve, which look like this. And the histogram would look something like that for rolling 3 dice. and it's even less likely that you would roll all 3 6s or all 3 1s. Okay, so this is called a normal distribution. Some things in many things in nature will follow this normal distribution, like the height of a I don't know, a turtle or something like that. So there's a bunch of turtles that are around the median or the mean, and that's what a normal distribution is, where the median and the mean are in the same spot. So there'll be a bunch around here, and then as you go out, there's, some turtles are taller and some turtles are shorter, and they fall into these very narrow ranges. Now there are some things in nature that their distribution looks something like this. And on the right side, there's a bunch that kind of straggle out. This might be the age of marriage, right? So maybe a couple people get married like when they're 17 or something like that, but a bunch of people get married around 25, 26 years old. And then there are and it kind of has a tailing trail, or a trailing tail, where, there's people that get married in their 70s and 80s that are out here too. So this would kind of be what we call skewed right. And then if it was the other way, it would be called skewed left. So wherever the tail is at, if it's on the right side, we call it skewed right. If the tail is on the left side, we call it skewed left. Okay, last thing I want to do is do a GeoGebra file and build a histogram on there. So here I'm going to do 50 different dice rolls. So it's 50 times with 3 d6. It's a 6-sided die. I'm rolling 3 of them, and I'm going to do it 50 times. And this is what this online die roller does. So I'm going to go and put all this data in. So like the first roll was a 13, then a 17, then a 10. I'm going to put all this into GeoGebra, and just like this. So I open this up, I turn on my spreadsheet view, so there it is, and I'll go and put all that data in, and see what to break. Okay, as you can see here, I put in all 50 of those numbers, and what I'm going to do now is make a histogram. Okay, now that we have the data in, I'm going to select all of these, so I just click and drag, and they're all selected, highlighted blue, and then I click on this one variable analysis, and I go to analyze, and that will give me a histogram of all that data that I just entered, and it could be split up in many different ways. So if I want to split it up into 3 categories, so this would be, looks like from 7 and below, so the number of times 7 and below is rolled, between 8 and probably 12, so the number of those that were rolled, and then between probably 13 and up to 18. Then if I split it up into a bigger pattern, just drag this bar over, so let's say I split up into 10 patterns. Looks like a lot more were rolled in this range. And bigger patterns. So this would be the individual rolls. So it looks like I probably rolled 2 17s. There's 17. And there's a 17. So it looks like 2 17s, probably only 1 16, 1 15. 2 14s, there's a 14. Yeah, 14 and 14 right there. And there was a whole bunch of 10s that looked like were rolled. 8, 9, 10. Maybe this graph doesn't space it very well, so maybe this is 9 and this is 10, 11, 12, 13, 14, 15, 16, 17. Yeah. So these gaps are probably artificial. There's no gap that should be there. Probably no twos are rolled because there's 3 dice getting rolled, so there's probably a couple of threes, right? Maybe 3 of them. 1, 2, 3. Yeah, so that's what ended up being the result there. So this is how histograms work and how you can modify the different ranges. If we want to just compare this to a box plot, so here's a box plot showing what the median was. The first quartile range goes from 3 to looks like 8, and then the second quartile, third quartile, fourth quartile. So it looks like most of the data falls right within that range from 8 to 13. And then the highest roll was a 17, right? We didn't roll any 18s. So that's the difference between a box plot and a histogram. You might see a dot plot. Here's dot plot is even more like a tally sheet. Stem and leaf plot just says what the first digit is and then the second digits. First digit, second digit. Okay, so that's different ways that you can represent things in GeoGebra.